Hi Geometry. This is Unit 5, Lesson 16, Part 2 on page 626 of our workbooks. So first of all, we learned in Part 1's video that the volume of a sphere is equal to the formula 4/3 pi r cubed, and the surface area of a sphere is equal to the formula 4 pi r squared. Thinking of, for example, a Cadbury egg, the volume would be the chocolate and the cream filling inside. That is what fills that circular shape. And the surface area is like the foil wrapping around the outside of our sphere. So in this problem, we're going to model an elephant, a big old elephant, with the idea it's like a sphere. It's big, it's round, it's large, and it has a radius of 4.5 feet. So it asked me what is the volume of the elephant and what is the surface area of the elephant. So I'd like to substitute my radius into my formula. The surface area to volume ratio. So surface area to volume ratio means surface area is my numerator, volume is my denominator for each animal. So let's start with the elephant. So for the elephant, if I put my surface area on top, going back to the previous page, that's 254.5 feet squared over its volume, which was 381.7 feet cubed. Don't cancel your units here. So I'm just going to divide the two numbers, but I am not going to cancel my units. So when I divide those two numbers, I get approximately 0.67, and that's feet squared per feet cubed. That is the surface area to volume ratio for my animal. It's really, really, really tiny. It's less than 1. Let's take a look at the snake's surface area to volume ratio. So for the snake, it was 1.948, I believe we said, divided by its volume, 0.094. Again, you might have slightly different numbers. When I divide these two, I get 20.7 feet squared per feet cubed. I know from class some kids get 18.7. It depends on how you round, but the numbers are really close and they're both correct. But that's a really large number compared to the 0.67 for my elephant. So let's think about this for just a moment. How does the surface area to volume ratio affect the biology of our elephant and our snake? So think about our elephant. He is warm-blooded. He's a warm-blooded animal. So this less surface area to volume ratio makes sense because he doesn't need to really lose heat or gain heat for his body temperature. However, let's think about the snakes. The snakes during the day, they uncoil their bodies and they lay on rocks in the sun so they can absorb all this heat because they have this big surface area compared to the actual volume of their body. And at night, they coil up really, 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 really tight in a tight spherical shape to have less surface area, so they lose less heat because the snake is a cold-blooded animal. So it needs to maximize its surface area to absorb the heat around them. And just as a minor side bit with elephants, their ears, their very, very large ears, do play a role in this. The ears do allow them to, because of the surface area, they do allow it to give off heat. For example, if they're very, very, very hot, they do serve a mechanism there. But that's really a more in-depth lesson in a different course. But this is the surface area to volume ratio for each of our animals. So suppose a human is a sphere. Okay, the human is a sphere with a radius of 1. The ant is a sphere with a radius, that's tiny, 1/200 units. And an elephant is a sphere with a radius of 5 units because the elephant is much bigger. That makes a lot of sense to me. Okay, you guys, so it says number 1, the raw strength. So the strength of this creature is the cross-sectional area of its muscles. Okay, in this case, if these guys are all spheres, by the way, if these guys are all spheres, then a cross-section is a circle. I have a lot of circles inside here. So this is a stack of circles that are changing in size. So we learned that earlier in the unit. So the cross section of each of our spherical beings is a circle of radius r, where r is the creature's radius. Order the human, ant, and elephant by their raw strength from least to greatest. Show your reasoning. Well, it seems to make sense to find the cross-sectional area of each one of these. So for an ant, my cross-section, which is a circle, would be pi r squared for the area, for the cross-sectional area. And in the case of the ant, it was 1 over 200 squared. So 200 squared is 40,000. So this is really pi times 1 over 40,000, or pi over 40,000. I could put that in my calculator in just a moment to find out what decimal that's equivalent to. Let's move on to do the human. So my human is pi times its radius is 1 unit, so that's 1 squared. So my human is just pi. And then my elephant's cross-sectional area is pi times its radius squared, which was 5. So in this case, my elephant is 25 pi. So without even putting pi divided by 40,000 in my calculator, which is a super, super, super small decimal, I can already tell this one's going to be the least. This guy will be in the humans in the middle, and obviously 25 times pi, 25 times 3.14, and on with my other decimals will be the greatest. So as far as putting them in order, they're in order as they're listed, from least to greatest. So relative strength, relative strength is given by the ratio of raw strength, that's what we just did in number 1, to volume. That's a fraction with raw strength in the numerator and volume in the denominator. This would be my numerator, and this would be my denominator. It measures how strong a creature is for its size. Oh, that makes sense. Create an expression for the relative strength of a spherical being with radius r. Remember that the raw strength formula is the cross-sectional area, and the volume of a sphere is this. So no numbers in number 2. We're just doing it with, we're creating a formula. So our relative strength, it tells me in the problem I just did, is equal to raw strength, that's from number 1, all over the volume. So raw strength was a cross-sectional area, which is a circle, divided by volume, and the volume of a sphere is 4/3 pi r cubed. So I just need to clean this up a little bit. So in this problem, my pi's cancel, nice. In the numerator, I'm not sure where your algebra skills are, but r squared is like r times r cubed is 3 r's, so I can see where I get my r's completely cancel, and I get just 1 r left in the denominator. Now 4/3 in the denominator, dividing by a fraction is the same thing as multiplying by the reciprocal. So instead of dividing by 4/3, I'm going to think of this as multiplying by 3/4. So I'm going to multiply by 3/4, and in the numerator, everything canceled to 1, and in the denominator, I have an r left. So this would be 3 over 4r. If I really lost you in the algebra, please come to office hours and we'll talk about it. But this is my formula for raw strength. So let's take a look at number 3. It says order the human, the ant, and the elephant by their relative, that was the formula for relative strength. I think I said raw. Relative strength, that's what we just found in number 2. This is how strong they are for its size. So let's start with the ant. So my formula is 3 divided by 4 times the radius, which is 1 over 200. And so in my calculator, I would do 3 divided by, now open parentheses, 4 times 1 over 200. When you do that, you should get 150. Again, if you're having calculator issues or if you're having difficulty with the algebra, please come to office hours so I can talk you through that. So in this case, let's work our way through human. that was 3 divided by 4 times its radius of 1, which is just 3/4. Wow, that's a super small number. That's really 0.75 compared to 150. And the elephant is 3 divided by 4 times its radius of 5. That's 3 divided by 20, or 0.15. So we can see here that the ant is obviously the strongest, the human's in the middle, and the elephant's the least strong. This is the greatest. But let's talk for a minute about what is this? Like, what does this even mean? So for my ant, for instance, it has a relative strength of 150, and my elephant has a relative strength, a human. Let's look at a human, us. We have a relative strength of 0.75. If I divide the ants by the humans, I find that when I divide that on my calculator, I get 200. The ant is 200 times stronger than the human based on its size. What the ant can carry around, what the ant can do, it's really 200 times stronger than we are. That's really kind of something to think about. So the ant was my greatest relative strength. My human is in the middle, and my elephant had the least relative strength based on its body size. So move on to the next page. I would like you to read the entire summary. Pause this video, read the whole page, and then please come back to this video. Welcome back. I just wanted to highlight a few things. First of all, in this middle paragraph, it talks about the surface area. If we want the rectangular prism to have more surface area, the best design is to make it wide and long. For example, this rectangular prism has a surface area of 492 centimeters squared. This rectangular prism has a surface area of 246 centimeters squared, and this cube has a surface area of 216 centimeters squared using the dimensions given above. Come to office hours if you want to talk about my calculations. So you can see, obviously, the greatest surface area was the one that had the really wide, long side. The 12 by 18 side turned out to be the rectangular prism that had the greatest surface area. So if you're going to be comparing some sizes, you're looking for one of my rectangular prisms, for instance, that has the widest, the longest, that biggest exposed surface. Now, shapes that are more compact, like a cube, as witnessed up above, have the least surface area. And for volumes that are equal, a sphere has the least amount of surface area. So if your volumes remain constant, your surface area will have the least, your sphere will have the least surface area out of all of your objects. So down here at the bottom, they're talking about our minimizing and maximizing surface area that we were working on a few minutes ago in class. So make sure you take a look at those, the summary, to wrap up our lesson. Thank you very much.